Hey, Marty. So guys, as we wait for everybody to join, if you saw your assignment in Google Classroom, we're not going into Nearpod until later on today. I'm going to end up just sharing my iPad screen with you so that you can watch the solid process on how to do scale factors, really summarizing everything that we've done. So a little bit more direct instruction from me, and then a few problems that you're going to do towards the end using Nearpod. But we have quite a few. We only have 9 in right now, so we have quite a few. So we're going to hang tight until everybody joins us. Declan, I did not get an email. It might still be coming through. I'm not sure where you sent it to. But as we wait for the rest of our class to join, I was explaining this to the few that were in here earlier. We are not going to go into Nearpod until later on in the lesson. I'm just going to end up sharing my iPad screen to show some examples so that those that are a little bit confused still on scale factors and things we've been working on can see a solid process on how to find it. And then I'm going to send you a Nearpod link towards the end of class for you to complete something on your own. As we're waiting, some of you are still having issues opening assignments that are posted. So there's 2 options, and I went this morning and responded to some of your assignments that you attached something to that didn't save, and I gave you a couple options. Option 1 is to always do something on line paper or graph paper or in the book. Take a picture of it and send it in. A lot of you have been doing that. That is perfectly fine. Option 2, it has been discovered that some of you who are using a Google Classroom website are having trouble opening. So if you try to just download the app will allow you to use a pen tool to just write directly over the PDF. So like some of you are being forced to open something in Google Docs or Google Slides and it's becoming a whole mess on trying to do that. Try to download a Google Classroom app instead of the website. And then in the top right-hand corner, there's going to be a pen and you can just click on that and write directly over it. So either of those 2 options, if you want to try for today's assignments, they are in the book. I know some of you were confused yesterday because I posted something, it wasn't in the book, and we talked about it 10th period. Today we're back in the book. So the lesson 4 practice stuff you'll be able to find. If you want to do it on a separate sheet of paper, you'll be able to find those pages in the book. Or like I said, try to download the Google Classroom app instead. We've been working and it seems to have been figured out that that's an issue that some of you are seeing. If you have the app, then you're not going to have to open it in Google Docs and have all of those formatting issues. Alrighty, so I am going to go ahead and get started. Like I said, I'm just going to share my screen with you. I'm going to do a handful of practice problems just to show you. If you want to have your Unit 1 book out, we are going to start on page 31. I'm not going to answer all of the problems, but really just have your book out to see the pictures because there's going to be lots of scaled pictures and I'm going to go through the process of how to find the scaled copies. I'm going to type my email in the chat. There you go. Okay, so yeah, if you need to go grab your book, that's perfectly fine. Like I said, I'm going to share my screen. If for some reason you get kicked out, you can't hear, things are going all funky for you, I'm always going to record this, not the Google Meet. I'm actually just screen recording the slides that you're seeing. So if you need some extra help or you want to go back, it should be pretty helpful to you. Okay, so you should be looking at my screen right now. So we're going to pretty much summarize everything we've been doing about scaled relationships. So we're going to be able to explain what corresponding parts are, how to use them to find scaled copies, and then emphasizing again that angles are always the same in scaled copies. A lot of you on the Edpuzzle video yesterday forgot that angles stayed the same, but after you watched it and answered those questions, were able to remember it, and that's what you put in that last question. So that was good. Okay, so like I said, we're going to start on page 31. And if you are using the book along with me, I'm not going to answer all of those questions. You really just want to have your book out so you can see the pictures as I work along with it. So we are given these three figures and we're told that they're scaled copies. So all I'm going to do here is go through and show you the process on how to prove that they're scaled copies. So the first thing I notice is the first condition that needs to be true. All of my angles are exactly the same measure. So if you're figuring out if two things are scaled copies, first thing you want to check for, are all of the angle measures equal? It's your easiest thing to do, doesn't take much math. So notice that first. If the angle measures are the same, then you want to go in and try and find the scale factor. Remember that your scale factor is the number that will take one image to its copy. So if at first I'm just going to look at figure A and figure E. So I'm just naming these shapes by the bottom points just to make it easy. So I want to figure out what is the scale factor that takes me from shape A to shape E. These pictures are a little bit more difficult because if you look at their edges, they are not going straight through whole blocks. So I cannot easily count what these diagonal lines are. If you ever find yourself in a situation where you cannot easily count the edges because they're diagonals not going through whole blocks, think outside the box. What else can I measure in this shape? If I look at distance DB going straight through, I can easily count that. If I count those blocks, segment DB in my original is 4, and then I'm going to count its corresponding part in shape E. So same distance here because it's easy. I can count straight across. I have 1, 2, 3, 4, 5, 6 blocks. So if I want to find the scale factor, I draw my arrow in like I did from the smaller shape to the larger shape. So the arrow will help you because you're always taking the end of the arrow divided by the start of the arrow. So I drew it going to shape E, so that means I'm going to take 6 divided by 4, because that's where my arrow started, and that's going to tell me 1.5. So then all I have left to do to find the scale factor is take one more side or one more pair of corresponding parts. So now I'm going to make a segment C down to A, again, because I can easily count those blocks. So I have segment CA, 1, 2, 3, 4, 5, 6, being 6 units long. And then if I go ahead and highlight its corresponding part down here, would be GE. I'm going to count that. I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So the length of that's going to be 9. And then I'm going to make sure I divide in the same way. So my arrow is ending at shape E. So then I'm going to take my numbers in E, which would be 9, divided by my length in A, which is 6. And if I divide that out, it's going to tell me 1.5. So that's your process behind finding your scale factor. If you get the same number, that's what your scale factor is from one image to the next. So scale factor from A to E is 1.5. So that tells you that everything in the first shape gets multiplied by 1.5 to make everything in the second shape. We're going to go ahead and do the same process, but now I'm going to find the scale factor from the middle shape to the third shape. So I already counted my parts in the middle, the biggest one. So now I'm just going to find the corresponding parts in the smaller shape. So where my length was 6 in the middle, I have a length of 2 on that smaller shape. And so I'm going to go ahead and try and find that scale factor from the larger shape to the smaller shape. Drawing the arrow helps me see how I'm going to divide because it's always the end of your arrow. So 2 divided by where your arrow starts, which is 6. So if you do 2 divided by 6, be careful that you're not doing it too fast. Bigger number is on the bottom, so 2 divided by 6 gives me 0.3 repeating. And then I'm going to go ahead and find that second pair of corresponding sides. So from K to I, if I count that length ends up being 3. So then again, I'm trying to find that scale factor. So if I go from the middle shape to the smaller shape, I have 3 divided by 9. So 3 divided by 9 in the calculator also gives me 0.3 repeating. So I got the same number. So that means that the scale factor from E to, there's no bottom point here, so I'm just going to use shape or J. Just any point on that shape from E to J is 0.3 repeating. If you know what that is as a fraction, we can also say 1/3. So everything in that middle shape got multiplied by 1/3 to create everything in the smaller shape. Okay, so that's the process you want to do whenever you're asked to figure out if something is a scale copy. We no longer just want to say they look the same. You're looking to see if the angles are the same. If they are, then you have to find that scale factor. So take one shape divided by the other shape. If you want to draw your arrow in to help you, you can. So I'm going to flip my screen. If you're in the book working along with us, we are moving to page 33. On page 33, you can see 2 W shapes, and this looks similar to something that some of you are a little bit confused on. All good, Declan. Some of you were asking me questions yesterday during 10th period about how can we easily figure out a scale factor if something's not on a grid. So we're going to look at that here. So I have the larger figure is a scaled copy of the smaller figure. So I know they're scaled copies. And then I'm going to read through question A. It says, if AE is equal to 4. So all I know right now is that length AE is equal to 4. So if I find that in my shape, notice that AE isn't even really part of the shape. It's just that top piece. So I'm just going to go ahead and label that in as 4. So if AE is equal to 4, how long is the corresponding distance in the second figure? So if I look over here, here's my corresponding distance. I need to know what that is. If I'm looking for missing segments, step 1 is to figure out, well, what is the scale factor? So I want to know my scale factor from the smaller w to the larger w. So since I drew my arrow, that means take the end of my arrow, which is 15, divided by the start of my arrow, which is 6. Okay, so this problem was nice because it gave me 2 side lengths. So I can use those 2 side lengths to find the scale factor and then use my scale factor to scale up to that missing length. So if you're using your calculator, 15 divided by 6 gives you 2.5. So that means that the scale factor is 2.5. So everything in that smaller shape gets multiplied by 2.5 to make the larger shape. So if I'm looking for this bigger distance here, if I know the smallest side is 4, I'm going to take 4, multiply it by 2.5, and that's going to go ahead and give me this bigger distance here. So 4 times 2.5, if you use your calculator, is going to give you 10. If you want to do that in your head, a little trick, you can always do 4 times 2, which is 8. And then half of 4 is 2. So 8 plus 2 also gives you 10. But using your scale factor and scaling it up, we find that HL is, Jackson, you should have picked your book up in orientation. So I found my scale factor using my lengths that were given to me. I divided them to get 2.5. And then 2.5 I used to multiply my smaller shape to get everything in the larger shape. Question B says, if IK is 5, how long is its corresponding piece? So similar question, but notice now they're only giving us information on IK. And that's in my bigger shape. So I know that length IK is equal to 5. I want to know what this smaller portion is. So I'm kind of doing the same thing, but now I'm moving backwards. I'm going from the bigger shape down to the smaller shape. So how do I go from a bigger number to a smaller number? Instead of multiplying by my scale factor, I'm just going to go ahead and divide. I have to use that same scale factor because it's true for all parts in my shape. But now if I'm scaling down, 5 divided by my scale factor of 2.5. So if you do 5 divided by 2.5 in your calculator, you're going to get a length of 2. So using that scale factor, 2 is the length of BD. Okay? So you find your scale factor by finding a pair of corresponding parts. That's what I did first. Corresponding parts were given to me. So I took one side length divided by the other. That gave me the 2.5. And then I used that scale factor to scale up my smaller side length. And then I used the same scale factor to scale down my larger side length. Okay, that's the process that you want to do. Divide your corresponding parts and then either multiply or divide depending on if you're getting bigger or smaller. Okay, I'm going to flip my page again. If you're confused on this, if you're still stuck, remember that I'm always recording these lessons, so you're going to be able to access it. You can join us again 10th period with some questions. But the last problem I'm going to just go through with you is on page 34. So we're given two quadrilaterals. And we have a question saying that student 1 says that polygon Z, I'm just going to call it polygon Z because it's easier. So polygon Z is a scaled copy of polygon X. But Noah disagrees. We have to figure out who we agree with. So remember, we have to check two conditions. You need to figure out if there's a scale factor, and you need to figure out if the angles are the same. Okay? Keep in mind that it's always easier to start with the angles, because if you determine that the angles are not equal, then they're automatically not scaled copies, and you don't have to do any of that extra work. So it's always easier to look at the angles and see if they are the same, especially in this one. Okay, if we take a look at this top piece here, segment XN corresponds to ZH, and then determine, do we think these are the same size? Okay, if we look at this, ZH is going directly through corner to corner. XN is not doing that. It's going through 3 blocks, not going to corner. If I look at this angle made right here that I'm highlighting, it looks a lot wider than what this angle is here. Okay, so I can just look at this shape and see that angle N and angle H are corresponding, but not the same size. So if you find that two angles in a shape that correspond are not the same size, you automatically know, so angle are corresponding but not the same size, so they are not scaled copies. If you determine right off the bat that the angles are different, they're not scaled copies, you do not have to do any of that work where you're finding the scale factor. It's always easiest as your first step to check your angles, because you can calculate that and solve that just by looking at it. I can see that angle N is a lot larger than angle H. So I'm not even going to worry about finding a scale factor. Angles are different sizes, automatically fails your scaled copies test. Not the same size, not scaled copies. If you wanted to go ahead and actually calculate your scale factor, I'm not going to do that here, but if I switch the slide, you can see I started doing it. I would do the same thing I did in the front, or the beginning of this. I counted these distances. You would divide them and you get the same scale factor. But again, if you measure the angles are not the same. So automatically you know it's not a scaled copy. Okay, so that's the two conditions you always have to check. Are your angles the same? Can you find a scale factor? What I'm going to do right now is send you a link in the Google Meet chat. Let me stop presenting so you can actually see. So I'm going to send you a link, and then in Nearpod, that's where it's going to send you. Once we all get logged in there, I'm going to give you a question to work on. Okay, so now I'm hoping that me going over this helped some of us that might have been a little bit stuck on calculating scale factors and finding scaled copies. So I'm going to send you to Nearpod, follow that link I just put in the chat, and I'm going to send you to a drawing page where you're going to calculate some scale factors. Go ahead and join that link I just sent. If you are using the app or you need a code, you can type in code GRLXM and it's going to get you into the same place. But I'm going to give you guys 3 minutes to take a little break. At 11:35, I'm going to push us into Nearpod. So follow that link, use the code, join into our Nearpod slides. Once you log in, you're going to see the same page that we just left off on. So just take a little break, 2-minute brain calm down before I move us on. There's a timer on the slide that I'm going to have you work on, so I don't want to start it without the whole class. And again, I'm going to say that if you are in the Google Meet, I can see your name. I can also see whenever you join the Nearpod. So I am aware of who's in, who's not. If you're having difficulties and it's not letting you, that's a different story. Please let me know about something like that. But make sure you're logging in. I am going to get us started in 1 minute. And then we are going to be done with class pretty early today, so you're going to be free to move on to your independent work. Okay, I am going to switch the slide. So not this one, not this one. Okay, so once I hit start, you're going to see 2 trapezoids. And then similar to the question we just worked on, you're going to have 2 students. One says they're scaled copies, the other says they are not. So think about what I just showed you. Think about what I did to determine if they were. And then you're going to work to tell me whether or not they are scaled copies. So you're going to have 4 minutes to work on this. And once we're done, I'll share out some of your classmates' answers. I'll share out my answer. Determine if they are scaled copies. Remember, there's always, both conditions have to be true. Angles have to be the same, and you have to find the scale factor between all of the side lengths. Your corresponding parts have to give you the same scale factor. another minute to finish up whatever you're working on. And then I'm going to share out, I'm not even going to share out my work because some of you have some really good reasonings behind why you said either yes or no. Okay, I am going to share some answers with you. So I really like what this student did. So are they scaled copies? No, because some of them are more than half. So what this student noticed is that those top segments, DC and HG was half of that. So 2 divided, or half of 2 was 1. So then they went and tried to take half of all of the other side lengths, and it didn't match. Half of 4 is 2, and that shape was written as 3. Half of 6 was 3, but that shape was written as 4. So they noticed that that scale factor of 1/2 from the bigger to the smaller wasn't the same. Perfect. I also like what this student did because we can see that they tested both conditions. So our angles are highlighted, showing that something went ahead, or somebody went ahead and noticed that all the angles were the same. So not as, or that condition works. But then when you go to check the scale factors, they're different. So you have to make sure you're showing both, which is, I really like what happened in that one. So you should say, no, they are not scaled copies, because even though the angles are the same, you have different scale factors. So we should agree with Lynn. So some of you phrased it as agreeing with Lynn. Some of you just said no, all good things. I'm going to put one more problem on the screen for you to work on. Same question, figure out if they're scaled copies. I'll share out some of your answers, and then I'm going to explain what the rest of your day is going to look like. Declan, I'm not sure why it said that. I saw your, oh, are you talking about your homework, or are you talking about this problem? The Nearpod stuff, okay. I can see, I saw yours, so it came through. I don't know why it said it didn't. I was reading what you were writing. I can, as you guys are writing, I can see step by step. So along the whole way. So when you submit it, I see your final answer. Through the whole process, I can see you as you are working. I don't know why it said that it wasn't. Are they scale copies? Guys are coming up with some really different ways to count the shapes. Very cool. All different ways of getting to the same place. If you think you can find a scale factor, then I'm going to push you to, and by asking you, did every single part of the figure change using that scale factor? This one is a little bit trickier because there are some parts that do move the same, but do they all is the actual question. I'm going to give you a couple more seconds to finish up whatever you're writing because I see some of you that are working are putting some really good thoughts out. So I'm going to let those that are almost finished submit, and I'm going to share out some of their answers. Okay, I'm going to share this one out first. Where did it go? Okay. So I really like this one because you can see that first step this student took was count all of the side lengths. So in the smaller one, I have side length 3, 1, and 2. In the larger one, I have 5, 1, and 4. Just by doing that, not even calculating, this student noticed that there was a length of 1 in both of those shapes that didn't change. So even though some of the other side lengths changed, that one stayed the same. Automatically throw it out. It's not a scaled copy because if it was, that one would have been scaled up like everything else was. Okay, you may also notice that 2 times 2 gives you 4, and then 3 times 2 didn't give you the 5 that she wrote in. Okay, so really good observation. Just by looking at it, you can see it's not the same shape. It's enough to throw it out. I also really like, you guys all had really cool ways of counting the shapes. This shape was a little bit more difficult to count because of those diagonals. So try to think outside of the box. Take a look at what this student did. So he couldn't necessarily count the diagonals, but all they did was draw a rectangle around the shape. So my smaller rectangle was 2 by 4. The larger rectangle was 4 by 6. And again, the same thing we talked about on that other page, 2 times 2 gives me 4, but if I count the height, 4 times 2 doesn't give me 6. So not a scaled copy because you can't find that scale factor. And again, it's always because if you look, the segment that is highlighted in this student's work did not change. So it's a length of 1 and a length of 1. So even though everything else might have been scaled up, the rest of it was not. So it didn't change with everything. You cannot find a scaled copy. Okay. So I'm hoping that helped some of you who might have been still a little bit confused on your scale copies. If for some reason it's not working and you got booted out, this was recorded. I'm going to post this onto Google Classroom. What you are responsible to do for the rest of the day, so with the rest of this period if you want. If not, you can just take a break. 10th period, you have an Edpuzzle video and then a worksheet to do. And remember, if you need help, come into the Google Meet. I'm always going to be here. If you are having trouble opening the document, like I said at the beginning of class, some of you are still having some issues, complete it in your book. This assignment is in the book with lesson 4, or line paper, or try to download the Google Classroom app. If you use the app, it kind of gives you more function to just write right on the PDF. But either of those options, go ahead and do that. But for now, you are free to sign out of this Google Meet, work on those independent assignments, and then come back in 10th period only if you need help. You do not need to come in, but I will be here to help with any of that practice work.